already given the definition of deep already given the definition of deep learning. Deep learning refers to the use of artificial neural network with the more than one layer or the neurons. So the deep learning is the simple neural network which include the more than one hidden layers: output layer, input layer. So that the information processing for supervised or unsupervised feature extraction and transformation, and for the pattern analysis and classification. It typically uses the deep learning artificial neural network. So a subfield of machine learning that is based on the learning several levels of the representation corresponding to a hierarchy of feature or factors or concept, where the higher level of level ones and the same lower level concept can help to define the many higher level concepts. See deep is the separation of machine learning and representation learning. The representation learning is a set of methods that allows the machine to be fed with raw and automatically representation or translation. So why is deep learning now? So the research this on this suggest the solution of the different some problems, and are there some solutions in the. So what is deep learning? So you can see definition of deep learning and simple working of deep learning and adaptive nonlinear mapping from the one space to another space. So there is a space 1 and space 2, and there is a bridge between the space 1 and space 2. So this particular three blocks, that is called the bridge, and this bridge uh, and these three blocks bridge the space 1 and space 2. So you have to have the solution in bridging the gap of space 1 and space 2. So for example, space 1 you have the written character, and you have to have the output in space 2. So you have to develop the model, you have to develop the problem. So you can predict the particular handwritten character. So particular in space 1, the handwritten character you can't understand, but in space 2 you easily classify or identify the character that is that is 3. So this particular model, the block diagram, process the particular character with the different hidden layer and provide the output. So this is the basic working of the deep learning model. So another example of space 1 deep learning. So space 1 include the simple input of a particular flower, and space 2 correctly identify the name of the flower, correctly identify the image name, that is the setosa. So these three particular block process the particular input image and gives the output. So you have to develop your model, you have to develop the machine learning model, so that the particular input will process and give the correct output. So particular particular deep learning include the input layer, output layer, and many more hidden layers. So these hidden layers play very important role to predict the model, to identify the model, to predict the model, and to classify the particular input to the correct class. For example, another input is a signal and the particular space to shows the output. So particular in signal in space 1 become as an input, and these three particular particular block process the signal and gives the output. So you have to develop your model so that the any input, the input in any form, either in the form of image, either in the form of signal, either in the form of character, your particular your particular deep neural network correct pre-process process the model, process the input and give the output. So so you have to develop your particular neural network that is include the many more hidden layers. So how to recognize the square from other shape. So you can write the different types of program, different types of algorithm to recognize the square from other shapes. So first thing we do is check the figure has four line or not. If yes, we further check if all our lines are connected and closed. If yes, if yes, then if yes, we finally check if all are perpendicular and all are and and so the same what of identify when you can image that is dog. So this is the problem. Identify the given image in the basket that is cat or dog. So you have to develop your neural network, and this particular neural network will take this particular image as an input, and the particular neural network will process the particular image and gives the output. And this particular image particular neural network include the different layers, input layer and activated neurons and output layer, and you will get the output that is dog. So your neural network must identify the particular input, particular correctly identify particular input. So this particular basket in the image that is dog. So given neural network that is called the deep neural network correctly identify the image that is dog. So the unique characteristics of deep learning make use of high dimensionality or dimension of data for training, defines higher level feature from lower level feature obtained from the previous layer, and it is a representation of it is a representation learning method and can solve the real world or unconstrained problems such as extra. So learning software, so you can take the screenshot of this particular image. So the list of some deep learning software, but not limited to the TensorFlow, Rhino, Keras, Blocks, Cafe, MaxNet, and uh, and my uh, cognitive toolkit, deep learning 4J, and DLib. These are the some deep learning software. So you can use one of them in your research purpose. So the category of deep learning architecture with algorithm supervised or discriminative deep learning and unsupervised or generative deep learning and hybrid deep architecture. So the supervised or discriminative deep learning. So the convolutional neural network, the type of discriminative architecture of CNN, the convolutional neural network is one of the most notable deep learning approach where the multiple layers are formed in the robust manner. So you can see the architecture of CNN, which include the different hidden layers and convolutional layer and max pooling layer and different fully connected layers and some output layers. And the some unsupervised or generative deep learning model. So this is the diagram that is given in the source, that is Gilo and et al. In 2016. And the application of deep learning. So some amazing application of deep learning are the automatic machine translation, the colorization of black and white images, and the object classification and photographs, and the automatic game playing, the character text generation. So these are the some applications of deep learning. The application of deep learning, so you can see this types of application in your mobile phone. So your smartphone provide the facility of Google Lens, and Google Lens is a set of vision-based computing capability that allows your smartphone to understand the what's going on in a photo, video, or a live feed. So this is the very important application of the deep learning, and this application in your smartphone, Google Lens. So Google Lens allows and the on your photo, video, or and add to this amazing uh, Google Lens, and you can check the different the information about the flower. So you can information to see the review other. So another application of the Google Cam. This is a situation where you are given the word in some language, and you have to translate the word the desired language, say English. So another application already include in your smartphone. So the translation is a very important application already given in your smartphone. So this kind of translation is a classical example of image recognition. So the application of image recognition already include in your smartphone. So another instance, visual translation. So you can easily identify the instant visual translation in your desired language. Another application, automatic machine translation. So you can see the another application of your smartphone, self-driving car. So the very important application of deep learning. So deep learning use case. So classical machine learning approach, we will define the facial features such as the eyes, nose, ears, and etc. And then the system will identify which feature are one or the are more important for which person on its own or by itself. So deep learning takes this one step ahead. The deep learning automatically find out the feature which are important for the classification because of the neural network, where in case of machine learning we had to manually define these features. So practical application of machine learning is facial recognition. So the we have already told that the deep learning is the artificial neural network which include the different layers, input layer, output layer, and many more hidden layers. So the in this the deep learning application in facial recognition, so you have to have some the different images, facial images, and these different facial images you have to take these facial images as an input, and you have to preprocess the data, and then the particular deep neural network process these different features and provide the result, provide the desired result. So you can see the facial recognition working, whole facial whole facial recognition process using deep learning. So the deep face recognition. So this include mainly two phases, phase one and phase two. So phase first, that is called the enrollment phase. So model system is trained using the millions of prototype face images, and trained the model is generated, and the generated face feature are stored in the database. And phase two, that is called the recognition phase. This is very important. So this is also called the query phase. Query phase image is given as input to the model, and to the model generated in phase one to recognize its correct.
Hello,
Yes,
hello.
yes, sir.
Uh, So
Yes,
your
sir.
voice is breaking in between, sir.
Okay, okay. So maybe some network
Okay,
problem.
you just continue, sir.
Actually, the PPT is very heavy. So,
Okay,
so the whole process is type extraction and prototype feature database, and the retrieve stored feature from the feature database, and query phase, the phase detection, pre-processing, the extraction, feature extraction, and some application. So the deep phase recognition, the steps within the enrollment phase and the steps within the recognition phase. So these are the some steps which are which we have to follow in the enrollment phase, and these are the steps which you have to follow in the recognition phase. So the phase detection, feature extraction, and store and the extracted feature in database. And these are the some steps which you have to follow in the recognition phase: the phase detection, preprocessing, feature extraction, and recognition. The step first, step one, phase detection, and that is called the enrollment phase. So phase detection, phase need to be located and region of the nearest is computed. The histogram of oriented gradients HOG is a faster and easier algorithm for phase detection, and detected phase are given in next step. And step two, feature extraction in the enrollment phase. So what is the best feature measure that represents the human face in a best way? In best way. So deep learning can determine the which part of the face are important to measure. So deep convolution neural network DCNN can be trained to learn the important features. And the step three, store the deep convolutional neural network model and feature in database, and that is the enrollment phase. And the step one in the phase of computed is called the HOG. So histogram of oriented is faster and easier algorithm for face detection, and detected face are given to next step of preprocessing and step two of preprocessing in recognition phase. So the process to overcome the issues like noise, illumination using anisotropic filters, and pose rotation can be accounted by using 3D transformation or affine transformation or face landmark estimation, etc. Third, the feature extraction and recognition phase. In this third step of the face recognition, we have to use the 10 DCNN model, which was generated during the feature extraction step of the enrollment phase, and query image is given as input, and this DCNN generates 20 feature values, and this feature vector is then compared with the feature vector stored in database, and this can and step 4, recognition. So this can be done using any basic machine learning classification algorithm like SVM classifier, basic classifier, or class, and side data recognition out. So how does the deep learning work? Let us understand the work of deep learning. So how deep learning is implemented through neural network, and motivation behind the neural network is the biological neuron. So you can say the different biological neuron and some artificial neurons. So in the learning neural network, you have to have the three things to develop your model. So asking a good question, learning neural network, and applying the design thinking. So asking a good question is very important to develop any problem, to formulate any problem. So what we want to do is just transforming the real world problem to a function. Then we use the deep learning technique to find the function. So you have the problem, and this problem you have to convert into the function, and you will get the output. So first of all, you have to have some problem, and then you have to find the function, and you will get the solution. So functions are the solution manuals. So I want to know what the animal in the picture is. So this is the problem. So first of all, you have to ask the question. The question, what is the problem, and the answer, the formation black bear. Another what is in the another picture, that is Python. So we have the partial answer, and we have another figure, another picture, that is the table with beer. So we have some question mark. So there might be infinitely many possible cases that haven't seen before. So the defining our functions by neural network. So in neural network, you have to have the problem, and the particular neural network include the input layer, output layer, and some hidden layers. So big three of deep learning neural network, the standard NN and CNN and RNN. So these are the some big three: standard NN, CNN, RNN. And the same thing we are repeating, asking a good question, seeing an animal is a wild. We want to know what is it. So transforming our question into a function. So the particular input image you have to transform into function, and this particular function gives the correct output. So in our real problem, you have to find the problem, and then you have to transform the particular problem into a function, and this particular function gives the output, and this particular function predict the correct output and classify the correct input into output. So first of all, you have to prepare the data set for the training. So we have already discussed that each and every machine learning problem related with the data. So without data, you can't apply the different the machine learning technique. So data play an important role. So first of all, you have to collect the data. And this particular data you can categorize into two categories. First one is training data, second is testing data. So the whole data you can categorize into two categories: testing data and training data. So yeah, you can use 80% data for training purpose and 20% data for testing purpose, and 80% data. So after collecting the data, you have to prepare the data like training purpose and testing purpose. So the data preparation required some pre-processing task like cleaning, transformation, and translation. So and then data selection. So you have to have some task relevant data for your research purpose. So this particular diagram shows the training data and testing data. So this is the third step, which shows the preparing the data set for training purpose. So you can say the beer formation black bear, and the Python. So Python is the testing data, and formation black bear is training data. So constructing the NN, so you can use any NN like standard NN, CNN, RNN, or BAV, and other. So once we decide our structure of neural network, we have a set of parameters need to adjust. Once we determine the parameter, we have a function that is called the f theta. So the learning is sent to our neural network using our training data, adjusting our parameter, and then using a loss function to see how much the difference we have and the observed value. So basically, we use the method that is called the gradient descent. For the normal neural network, the method is called the backpropagation. So I want to know the closing price of the stock market. So this is the problem. So we have to formulate this problem into a function. So the data x and the function and the output, the closing price of the stock of x. So these are the some different inputs, and you can use any neural network, NN, CNN, RNN, and you will get the XT. So use the price of the previous week to predict the price of the next week. So in this way, you you can formulate the problem, and you can develop your model, and you will able to develop your neural network. So I want to know how many homers a particular MLB player can hit the 2018 session. So these are the different features and the performance in the last year, and you can predict the number of homers in the year of T this year. So the chatbot, so the current word, and this can be converted into function, and you will easily predict the next word. So I want to use AI to play the games, driving a car, brew coffee, etc. So you have to have the problem, and you have to formulate the problem into function, and you will get the best move. And the reinforcement learning, you can use some character some character are missing in the font, so you can correctly predict the font. So the AI core technology principle of the neural network. So remember, we just have to learn a function. So we have the different input already. We have using the some black monsoon beer as an input and function and output. So this particular function in taking many more inputs and giving the many more outputs. So three steps of learning function: transfer a real world problem into a function, and collecting the training material that we know correct answer and find the functions. And black box learning, there are really a technique for learning arbitrary functions that is called the neural network. And neural network we have already discussed in the time storm. So the any neural network include the different different inputs, hidden layers, and output layers. So the black box play an important role. So you have to formulate the black box, so it will correctly process the inputs and correctly predict the output. So what is the powerful is that the neural network will learn everything, and you don't have to tell it what function should look like, linear, quadratic, and polynomial, and so on. So open the box. So this is called the standard neural network, and that is fully connected and very popular since from 1980. So the neural network include input layer, hidden layer, and output layers. So the artificial neural network. Let's uh, get real and artificial neuron, and it includes some input and also connected some bait with neuron and output. And you can also add some another important factor, that is called the bias, and you will get the output. So input also connected with bait and neuron, and you will get the output. So the output is the output equal to input into bait plus bias. So you can see the above neuron with input, output, and bias. So another representation, the output input into bait plus bias. So the neuron with two inputs, so input one and input two, and it also include two bits, bit one and bit two. So what will be the output? Output equal to input into bit one plus input into bit two plus bias. So the whole neuron you can see in the diagram. So input one include connect with the bit 1, and input 2 connect with the bit 2 and bias, and activation function if the value is low, and so it goes to 0. And there the action of every neuron is basically the same. So the particular neuron include the different input, different bits, some bias, and some and single output, and with some activation function. So each neuron accepts several inputs and then send one output. So mathematically, you can write this particular whole thing. The summation I goes to 1 to 3 wi xi and plus bias b. So you can add this particular parameter b and apply the activation function to the weighted sum. So the h equal the psi of summation of I goes to 1 to 3 wi xi plus v equal to h. So the whole thing you can represent in the form of in mathematical form. So these are the some popular activation functions: the RE, LU, recent and sigmoid, and the Gaussian. So the parameters are base biases, and the x1, x2 are the input, and w1, w2 weights, and psi the activation function. So the whole things you can write mathematically: psi of w1 x1 plus w2 x2 b1 equal to h, and the learned neural network. So you can assign some value. The bit 1 equal to 1 and b1 equal to 1 and bit 2 equal to 2, and you will get some value result of this particular particular neural network. So suppose we have the input x1, x2 equal to 1, 2. So these are the some inputs 1, 2, 1, 3, and bit 1 and 2 and bias 1. So the result will be 8. So psi 8 equal to 8. So this is the using RELU as the activation function. So you can easily find the value of this particular neural network. So the training method. So NN needs to be trained using the previous exam questions to train our neural network. Neural method is called the back propagation. So the function space for our neural network, when the neural structure is determined and activation function are also determined, it can be adjusted by the weights. Biases we call the set of these parameters theta, each of which defines the function, and we treat it as a set, that is f theta. and we are looking for theta star. So makes f theta use the closest to the objective function. So what does the closest mean? Mean that means the value of loss function, and loss function will be minimum. Suppose we have the training data set x 1 by 1, x 2 by 2, and up to xk by k, and the most popular loss function that is given by the L theta, and L theta is given by this mathematical equation. So uh, and the uh, uh, value of loss function must be minimum. So you can see the different uh, value of x and the neural code output and the true value and some errors. So these are this value of x, and these are the neural code output and true value, and these are the errors. So can be uh, uh, just add of them. So we can square the error and we get the sum of that is 56. So basically do such adjustment, and the eta is called the learning rate. So uh, learning rate del uh, L upon del Wij, and what does this the terrible thing means? Remember that L is a function of W1, weight 1, weight 2, and vice. So the smaller is the better. So for the simplification, we first think of L has only the variable W. So how to get the minimum? So we have some very important thing uh, in mathematics that is called the tangent. So I know a point to move the how to see it. So tangent is the key. So we can find the tangent. So, so tangent the slope of less than 0, and the slope of the tangent point to the local maximum maximum direction. So the tangent slope is the rate of change. So you can see the value of LSA and LSB. The pointing the local maximum, the tangent slope LSA, and tangent slope of LSB. So they moving toward the local minima in order to make the value of the loss function L smaller. We should adjust the weight W minus L d L upon dW. Suppose we should so we can adjust bit using the L is less than 0. So at A, so sometime it will run over. So you can find the B minus L the plus 10 L dash B greater than 0. So moving toward local minima in order not to make too much adjustment at one time, we will multiply a smaller number called the learning rate, called the W minus del W more. So for example, L function of W2 is, so suppose we have the W1 equal to 1 and W2 minus 1 B2, and then we are moving toward the local minima. Then only the parameters say it is W1, and you will get the LW1 equal to 4W square 4W square 1 and one variable function. So similarly, you will get the other value LW2, LD1, and you will get the different value W1, W2, W1 minus eta dl W1 upon W1, W2 minus eta dl LW2 upon dw, and B1 B minus eta L on dlb. And in this way, the writing it together seem more learned. So the different weight W1, W2, and W3. These are the updated weight, and W1 W1, W2, and W3 minus theta. In this way, you can find the updated weight. So the partial derivation you can write in this del L upon del W equal to d L W1 upon d W1. Similarly, we can write the same things. So the gradient, recall the gradient of L is, so you can say the gradient, and the gradient you can represent the del L equal to this. So the formula of W1 W2 V1 minus eta del L. So in this way, you can find the learning rate and the different things. So the another thing that is called the CNN, that is called the convolutional neural network. This image recognition. So this is very uh, the image in here, and your as a poor another application comes in the so the current state predict the next state or the next move. A conventional network input input output layer and different hidden layer convolution other you say of different some and apply the filters. So the convolution uh, layer uh, down. So different different pixels three filters. So the W equals 0 1 1 1 3 2. So this is the yes cross 3 filter. Another 3 x 3 filter, and you will fill the another same matrix. So in this way, you can find the different values 3 x 3 filter,
Sir,
and in this way,
sorry for the
yes,
interruption,
yes,
sir. Sir, your slides are not visible.
okay, okay. Uh, 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 Please give some permission to the slide. Okay,
Just a
okay.
minute, sir.
It's, it is sharing.
So the permission is already given.
Yes,
So kindly share this PPTs.
yes, yes. So, mm, is it visible?
Now it's visible, sir.
Uh,
Now the slides are visible, sir.
Okay, okay.
You just
So
kindly carry
actually,
on, sir.
I am yes, yes. I am talking about the convolutional neural. This convolutional network include the different layer, input layer, output layer, and different convolutional layers, max pooling, some other layer. So the convolutional layers includes use some filters. So we are talking about the 3x3 filters. So the input image, uh, given input image represented by so the pixel, uh, the particular image, particular given input, uh, 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 take some uh, small filters for particular input we use three class filter, and after using class three filter the another input using same input, the uh, and put uh, say like 31 and that is so using the different filter we prepared the another input from the given inputs. So neurons look like this. So this point on the picture are the one input layer neuron, the basis of some filter. Another it is matters. It is called the also consists the some uh, a lot of neurons. So you can use 3x3 filter to create the another input matrix. So after applying 3x3 filter, you will get the another input matrix. Uh, in this way, you will get the this matrix. Finally, we get the 6x6 matrix, and usually we use the make it 8x8 matrix, and we have a lot of filters. So the uh, input layer and the convolutional layer 1, convolutional layer 2, the neurons in the first convolutional layer are connected only to the pixel in their perceptive fields. So the perceptive fields and each neuron in the second convolutional layer is said on in the next hidden layer and so on. And this hierarchy structure is common in the real image. So the convolutional layer, and this is the input layer, and this is the convolutional layer, and this is the in receptive fields. So you can apply the different types of filter like vertical filter, horizontal filter, and you can see the particular convolutional neural network. And there is an image that is the handwritten 6. So this image can be represented into the form of pixels, and your convolutional neural network takes this pixel as an input, and the your convolutional neural network use the different filters and different max pooling and so on, and gives and goes to the output layer and predict the current prediction. Another that is called the max pooling. Max pooling. First one is the filter max pool. So basically, voting is to have one representative set 2 cross 2. So the given matrix uh, you can use 2 matrix, and you can use the max voting to yeah, use minimum in 4 values 35, 27, and 36. 4 is value in values. Select so in this way you can see the max pooling example. If you have 3 values 1, 2, 3, and 5, so you will select 5. 5 is the max value. So this types of scoring is called the max pooling. So you have to perform the max pooling to create the another input for the next level. So the complete architecture of CNN, which includes the input, output, and convolution pooling, and some fully connected layers. So each and every convolutional neural network include the input layer, output layer, and different convolution layers and max pooling layer, then convolution and max pooling layer. So internally, the CNN converts the particular input in different forms like convolution, first convolution, second convolution, max pooling, then convolution, and max pooling. So the whole input goes through different convolution layer and max pooling layer, convolution layer, and max pooling layer, and goes to fully connected layer, and finally you will the CNN provide the output, desired output. So in this way, the complete output, complete solution you will get. So we can repeat and repeat convolution, max pooling, convolution, and max pooling. So after we finished, we spent output of the normal neural networks. So the image net, so the image classification is challenge. So you can use any software to classify the images. So this is the example of different this actually and the to the conditions execution for example in to the neural network with many layers. The artificial deep learning. So this is the simple artificial neural network and include many more layers. The deep learning include a particular image, image is an input, and particular image is represented by pixel, and this particular neural network takes this as an input, different pixel goes goes with different convolution layer, convolution and exponential layer and the connected layer, and after after processing it will gives the output correct prediction, that is cat. So you can see the example of the 4 pixel image. So these are the 4 pixels and category images. So you can see the different pixels, solid pixel, vertical, diagonal, and horizontal. And this is the deep neural network example in which you take the you are taking the particular 4 pixel image as an input, and these different input goes to the next layer, and this particular diagram shows the different input layer and some different weights, and calculate doing the calculation of the simple neural network input, weight and bias, input, weight and bias, and gives the output. So activation function value is 0.7, and the sigmoid activation function and sin x equal to 1 upon 1 plus e to the power minus x, and this sigmoid function no matter how big your x can grow, and your sigmoid x will always be between 0 and 1. So the activation function value, that is 0.66, and the input of the neuron, that is 0.7, and the weighted sum plus activation function equal to neuron, and this is the complete working of this 4 pixel image. So weighted sum plus activation function equal to neuron, so that is 0.66, and let us make more neuron connected with different bits 1, -1 and 0. So you have to use another input for the another layer. So you internally it use the different use the different filters and max pooling concept and convolution, and again calculate the different values, and in this way this function will calculate the different values. So after executing the whole different layers, and it will provide the output, the solid, that is 0.73, and vertical 0.5, and diagonal 0.7, and horizon 0.85. 0.85 is maximum. So horizontal will be maximum. So another typical CNN, cat, the image of cat as input, and this particular input goes from the different layers. So it will provide the score for the cat 0.9, for dog 0.05, and for car 0.01. So the score 0.9 is maximum. So cat is correctly classified. So how AI work in its sliding window. So these are the some another application of CNN. So I think I have given the lecture in 90 minutes. So I will summarize the whole presentation, whole talk, and the coming slides. So the RNN, so recurrent neural network and neural network with memory. So these are the some uh, application of the RNN, the translator, video capturing generator, context generator, and drawing, and some lot of things are remaining. And the third, that is called the design thinking and uh, uh, problem solving. So this is the last design thinking, creative problem solving. Uh, uh, repeat, prototype, and test. Very close to the engineer's approach, and our model is really successful for the first times. And ये आपका जो Singh National University author, MLB player. So you can apply your machine learning approaches for the different problems. So you have to you have to you have to formulate your problem, and then you have to develop your function and correctly identify your output. So in this way, we are going to finish our problem, our presentation. These are issue. So the scalable architecture and partial data processing. So हम लोग लास्ट स्लाइड की ओर पहुंच गए हैं. ठीक. These are the some research issues handling real-time video analytics and distributed cloud, efficient graph processing at scale, identifying fake news in near real time, and the dimension reduction approaches for large-scale data, and inference in noisy environment and incomplete data, handling uncertainty in the big data processing, anomaly detection in very large scale system, effective and sensitive field of the large scale system, secured federal learning in real world application, is scalable privacy prevention in on big data analytics on to conversion of algorithm and context sensitive large scale system. And the in the beginning, I have already told about the data. Without data, we can't do anything in a machine learning problem. So the big data, play the big role in the research in learning. This source of the big data with 8 V's. So you can see different 8 V. First V volume, second V value, third V veracity, fourth V visualization, fifth V variety, sixth V velocity, and seventh viscosity, and eighth V, that is called the virality. So the researcher, the other student can work in different V like volume. You can see the information data increasing day by day in large volume, value, veracity. तो ये आप काम कर सकते हैं इसमें. और थैंक यू. हम लोग लास्ट स्लाइड पे पहुंच गए हैं, तो थैंक यू सभी को. ये
Thank you very much.
90 मिनट तक ये आपसे जी. और थोड़ा सा बीच बीच में इंटरप्ट किया तो उसके
कोई नहीं सर, it was very
तो कुछ ऐसे क्वेश्चन
was
हो
very
तो आप पूछ सकते हैं. थैंक यू.
any any participant having any question? Anybody from the participants having any questions, any query? So I think there is no query right now. So I would like to say thanks, Dr. Ghanshyam sir, on behalf of Computer Science Department as well as the Central University of Rajasthan, that you have given your consent to deliver lecture on such a nice topic, and you have delivered the lecture in a very nice way on a very current topic, that is deep learning. And then you have also told us about that, how the machine learning and how the deep learning and how the AI is related to each other. In that way, it was very good session, and I have especially I have learned a lot out of your session, and I think everybody have enjoyed the lecture and have got something, some particular. I think somebody is raising some hand. Malika Acharya is. So Malika, you've got any question? Malika Acharya? I think there is no question. Huh? So thank you very much, sir. Thanks for your nice lecture. Thank you very much, sir. So now I would like to request all the participants that I'm just going to share the feedback link for the current session, and kindly fill it and submit it. Okay. So now the feedback link is with you on your chat box. So you just fill it. And once again, I would like to say thanks to all that I'm just going to wind up the meeting right now. If you've got any query regarding any session or anything about the FDP, you may ask right now. Is there any query? I have requested all the speakers of the different sessions for the study material or the PPTs what they have used during the lecture. So as soon as the things are available, I'll share on the Google Classroom. As one of the speaker has shared the material, I have already shared on the Google Classroom. So because you know that at the end of this FDP, in the last session, we are going to have a test based upon the different session what we have conducted in the FDP. I will be conducting the FDP. So you're also supposed to be prepared for that also, and be regular in the sessions, because I think in the third session I'm having very less number of participants, like 80 or 85 participants are there, not more than that. So you people are supposed to be there. So I have already shared some material, so you just go through that, and as soon as I'm going to get, I'll share. Okay, because I'm not having the material right now with me, because as soon as they will be shared with me, I'll share with you all. Other than that, any query?
No, sir, we don't have any question.
Okay, thank you very much, sir. So I'm just going to wind up the
Thank you,
session
sir.
right now. Okay, thank you very much. And you are also having the feedback link in your Google Classroom also. Okay, you can also go there and then fill the feedback form. Thank you.